Hello, ladies and gentlemen. We've got ourselves an exponents and logs test, so let's do a little crash course. We'll see if we can review the whole unit. First thing here, if you need to find the inverse of a function, you want to flip x and y, and then the goal is to isolate y. We're trying to get y by itself. So to do that, you need to get this exponent by itself. So I'm going to subtract 5. Now on the left side, I have x minus 5. On the right side, I have 3 to the y minus 1. You have a base 3 exponent, so what you need to do is convert this to a log. You need to have a base 3 log. 3 to the y minus 1 equals, we're taking the base 3 log of x minus 5. And the last step to get y by itself, you have this minus 1 over here, you're going to add 1. So 1 plus the base 3 log of x minus 5. There's your inverse, here's your original function. Let's try another one. Here I'm starting with a log. I'm still going to flip x and y, so now my output becomes my input. Base 3 log of x minus 2 plus 5. Now we're trying to get x by itself. Well, that's y now. I'm sorry. Let me erase that. When you flip x and y, you need to make sure x becomes y. So now that's y. Now, to get y by itself, you're going to subtract 5. So on the left side, you have x minus 5 equals the base 3 log of y minus 2. And then we can rewrite it as an exponent. So if you have a log that's base 3, now it's a base 3 exponent. 3 to the x minus 5 equals y minus 2. And kind of similarly over here, last step, you need to add 2. So 3 to the x minus 5 plus 2. Now you have the inverse. Here's your original, here's your inverse. So flip x and y, and then solve for y. Next up, expand logarithms. So the big thing here is you have multiplication. So multiplication expands into addition. So when you had one log, now we're going to write this as plus another log of x squared. So 6 times x squared gets split into addition. Now the other rule that we need to use for this problem is the exponents. That power can come out. That's 2 times the natural log of x. This becomes a coefficient. So now we have 2 natural log x. This part doesn't change, so natural log of 6 plus 2 natural log of x. That is completely expanded. Let's do the same thing over here. Remember, there are implied parentheses, so we're going to split up the numerator, 4x cubed, with the denominator, but division expands into subtraction. So now it's the numerator, the log of the numerator minus the log of the denominator. We can still split this up, and this is very similar to this problem. We would have the log of 4 plus the log of x cubed because multiplication expands into addition. And the last rule is you still have an exponent in here, so this is 3 log of x. The rest of it doesn't change. Minus log of y. So log of 4 plus 3 log of x minus log of y. That is completely expanded. We've used all our rules to expand it as much as we can. Whoa, that's weird. Okay. What if we go the other way and we try and condense? So condense means we're going to take those same rules, but we're going to apply them backwards. First rule is that 4 can go back on the inside as an exponent. So can the 1/2 plus log of 64 to the 1/2. I'm not going to do anything with this one. One quick thing, 64 to the 1/2 is 8 because 1/2 as a power really means take the square root. So the square root of 64 is 8. Now we're going to do the same thing we did before. We're going to put this back together. Addition condenses into multiplication. So now it's 8x to the 4th. This isn't going to change. But you still have subtraction. You still have 2 logs. So the last rule is the 2 logs here are going to condense into 1 log, and they condense into division. So 8x to the 4th over y. So now that's completely condensed. We had 3 logs. Now it's 1 log. We're going to do something similar here. First thing we'll do is put those exponents back in. This 2 goes on the inside of the log as an exponent. Now I'm going to condense subtraction into division. And in this problem, we can actually simplify that. If you have 2 x's in the top and 3 in the bottom, 2 of them will cancel out and you'll just have 1 in the bottom. So the natural log of 1 over x is your completely condensed and simplified version. Okay, let's solve some, there's a couple different things here. This one's exponentiation. This is really more just solving. So exponentiation means you're going to try and make these have the same base. So 5 to the 3x, and 25 is really 5 squared. But we still have an x minus 1 in there. So exponent rules say you need to multiply, so 2 times x minus 1. See how these have the same base? That means that their exponents have to be the same. 3x has to equal 2x minus 2. If you distribute, you get 2x minus 2. When you subtract to the 2x, you get 1x, and that means x equals negative 2. That's your answer. X can be negative because you're taking 5 to a power. It's not a log of a negative, so you're fine. This isn't really exponentiation, but we're going to get that exponent by itself. 10 to the x plus 3 equals, if you subtract 3, you get 25. And now we're going to rewrite it as a logarithm. So this is a log with a base of 10. That's just implied to be base 10 if you just write the word log. But 10 to the x plus 3 equals 25. So when you rewrite it as a log now, you get the log of 25 equals x plus 3. Last thing you need to do is you need to take the log of 25 and you need to subtract 3. Now that's something we could actually figure out. We can take the log of 25 and subtract 3 using our calculator. Let's see if I can do that. Let's show up. No, it doesn't want to show up. Log of 25 minus 3, 3 is negative 1.602. So x equals negative 1.602. Again, you're not taking the log of the negative number, so that's okay. You can do that. Let's see if we can solve by rewriting logs. If you're going to rewrite a log, you need to have the log by itself, and then you need to take it as an exponent. So the base is 2. 2 to the 5th equals x plus 1. 2 to the 5th, 2, 4, 8, 16, 32. That's 32. So when you subtract 1 from 32, you get x equals 31. We're going to do the same thing here, but we need to get that natural log by itself. So the first thing I'll do is I'll subtract 2. 5 natural log of x equals 10 if you subtract 2 on both sides. Then I'm going to divide the 5 out, and I get the natural log of x equals 2. Now we can rewrite this log as an exponent, but you have to remember natural log is base e. So e to the second equals x, and then I can use my calculator to again, whoa, I think it was there. I can use my calculator to say e squared is 7.389. So x actually equals 7.389. If it says write your answer as a decimal, you need to make sure you write your answer as a decimal. Okay? So first thing we did was we subtracted, then we divided, and then we had the natural log of x is 2, so e squared is x, that's 7.389. Let's try, oh, wait, there's 2 of these? Okay, well, we don't need to do that again, we just did it. Solve when there's a log on both sides. These are actually the easiest problems because you're taking the natural log of these 2 arguments. That means the arguments, the thing that's inside the log, these have to be equal. So when you subtract 2x, you just get x, and when you subtract 5, you get negative 1. So you move all your x's to the left side, you move everything else to the other, and you get x equals negative 1. This guy is a little tougher. You see how there's 2 logs on the left? You need to condense that first, and addition condenses into multiplication. So the log of 3x equals the log of 30. Now it's like this, where you can say, well then 3x has to be 30, which means x has to be 10. And that's your answer. So the log of 10, which is 1, plus the log of 3, I don't know, will end up being the log of 30. Condense and solve, this is very similar, but we're going to treat it as an exponent because you don't have the log on both sides. Here, we're going to condense it. So base 2 log of x times x plus 6 equals 4. Also, you might have a slightly different version. Make sure you fix your problem. Make sure you have the same problem as me. Next up, we're going to write this as an exponent. So 2 to the 4th equals, I'll distribute, x squared plus 6x. 2 to the 4th is 16. So in this problem, we're going to have to collect everything on one side, set it equal to 0. Wait, why did I say 16 here? This is 6. But when you subtract that 16, you get minus 16. So x squared plus 6x, and you move the 16 over. Now this is factorable. What multiplies to 1 times negative 16? What multiplies to negative 16 and adds to 6? X squared, that would be plus 8 minus 2. So I'm splitting the middle with the numbers that meet this criteria. Now I have x plus 8 minus 2. This is called factoring by grouping. And my factors are x minus 2, x plus 8, and I want to know when they equal 0. So the first one, when does x minus 2 equal 0? That's when x equals 2. This equals 0 when x is negative 8. But you got to check to see if these are extraneous solutions. You cannot take the log of a negative number. So if you plug in 2, log of 2, that's fine. 2 plus 6 is 8, that's fine. Okay, 2 works. How about negative 8? Can you take the base 2 log of negative 8 if you plug negative 8 in there? Nope, you cannot take the log of a negative number, so this does not work. Our algebra was done correctly, but this is called an extraneous solution. It doesn't solve the original problem that we were trying to solve. Our arithmetic was all done correctly, but this doesn't solve the original equation we were given, so it's called an extraneous solution. We're going to do the same thing for the last one here. We're going to condense it. So x times x plus 1, and that equals the log of x plus 9. So now this is more like the other ones we did where we had just the log on both sides. We have the log on both sides, so we're just going to ignore the logs and say x squared plus x equals x plus 9. And when you collect like terms, you subtract x on both sides, it cancels out on both sides. So you have x squared minus 9 equals 0. I'm going to solve it by factoring. That's dots. X plus 3, x minus 3, which means x is either 3 or negative 3, x equals 3, or x equals negative 3. However, again, you can't take the log of negative 3, so this is extraneous. The only answer is 3. X equals 3. That's the only one that actually solves the original equation. So, last section here is a couple word problems. You have a formula that you need to use. You guys should remember this formula. P is the principal, so 3,400. 1 plus R is the interest rate as a decimal, 0.0115, so 0.0115. N is the number of times that it's compounded in a year. So if it's done semi-annually, it's done twice a year. And then N is 2 times 5 years, so 10. Now we need to type this in our calculator to get the actual value. 3,400, 1 plus 0.0115 divided by 2, and I'll do this in my head, 2 times 5 is 10. So to the 10th power, you get 3,664. So $3,600.64 is the balance. After 2 years, you made just over 200 bucks. Or 5 years rather. After 5 years, you made just over 200 bucks. It's not a bad deal. Let's do another one, but we'll do it quarterly. So very similar. 1 plus 0.0115. Quarterly means you do it 4 times a year. And if you do it for 12 years, we're going to have to multiply that out. So we do the same thing. I'll actually just steal that from before. But what changes is we're doing it quarterly. And if you do something 4 times a year for 12 years, you end up doing it 48 times. 3902.34. 3902.34. So if you do it for 12 years, you end up making from 400 to 900, a little over 500 bucks, which is pretty sweet. Again, that's the balance. So after 12 years, you do nothing, but you make $500. Cool. All right, Max buys a boat for $31,000. It depreciates by 9.5%, which is 0.095 as a decimal. Use the decay formula right there, which is pretty much the same formula as this one. You just make it a minus sign. And it's done annually. So after 5 years, we have $31,000. 1 minus 0.095, and after 5 years, we'll do 5. So let's type that in, 31,000, 1 minus 0.095 to the 5th. I got 18,819.35. 18,819.35. So the boat, after 5 years, is now only worth $18,000, a little under $19,000. Which is kind of a bummer. And the last thing says, let's say 10 years from now, somebody offers you 10 grand for the boat. Well, is it worth 10 grand? Let's take that formula and change it to be, it's now 10 years. After 10 years, the boat, according to this formula, should be worth $11,424. So if it's worth $11,424 and somebody offers you, and 77 cents, don't forget the 77 cents, and somebody offers you 10 grand for it, should you sell it to them? Well, I mean, this is kind of nuanced, which is good. I want you to think about it. If somebody said 10,000 bucks for an $11,000 boat, that's pretty close. So like maybe that's a good price. Maybe you want to negotiate a little bit and say, how about you meet me in the middle? Like 10,700 or something like that. Or maybe like there's some damage to your boat, so you don't actually need to sell it for that much. Like, oh yeah, it's got a ding in it, so we'll just take that out of the cost. It's tough to say, kind of depends on the boat, but you should be able to explain to me that, well, it's worth a little bit more than that, so maybe we need to talk about how much we should actually charge for it if you're going to sell it on Craigslist or whatever. So that's it for the unit. If you can do the crash course and you can do the study guide, you guys should be good. So thanks for watching.